So this is lesson 6.3a in college algebra, and we're going to touch on the hyperbola. And from the picture that you see here, we have this is a horizontal hyperbola, and if we took this and flipped it this way, it would be a vertical one. But let's go ahead and leave it horizontal there, and we've got a couple things to go over here. First of all, we have two focus points, which are called, when you're talking plural, foci. And we have what is called a transverse axis, which that is the one that goes through the two vertices there. And if we flip that over, it would be the transverse axis would be on the y-axis instead of the x-axis. Alright, so let me get rid of this and we'll just jump into some problems. And we can get rid of that one too. But notice on this one here that we have C, which is what we used. Alright, we've got an A, B, and a C. So basically what we have is a squared plus b squared equals c squared. Okay, so we've got a formula there. And if we're only given a and b, then we can find c, or b and c, and we can find a, etc. So that's the formula. And the c is part of the foci. The vertexes, or vertices, are the a's there. And then the b's are if we have a point here and a point here, and we have a distance there. This is a b, and that is a negative b there. Okay, so let's go ahead and look at what we're going to do with all that stuff. And so let's get, if I can get it up here, there we go. Alright, so there's the information. This is if the hyperbola has the center at the origin. So here's the formula for a horizontal. Here's the formula for a vertical. Difference is the a and b are the same. It's just the x and y switch places. And why that's important is because there's a negative sign. So because there's a negative sign, it does matter that they switch places. Alright, the vertices are here and here. And those are going to be negative a0 and a0. So there's a0 pointing to there, and negative a0 is pointing there. So what they're saying is the distance from the center point of the hyperbola is going to be a this way, a that way, but this direction is in a negative direction, so it's going to be a negative a. Same with the c and the c. These are the foci. And then your b's here. These are called a conjugate axis. You've used conjugates before. And so what we've got is a conjugate axis, which will be this distance from here to here. So here to here is b, here to here is also b, but it's negative b since it's the opposite direction. So that's what the a, b's, and c's are. Okay, so let's go ahead and do some problems here in just a minute. But before we do that, one of the things that we learned a long time ago is this word, asymptote. And we're going to make that plural because we're looking for two asymptotes. Alright, so what we're going to do is we're going to, and this is what we use in order to graph these. We're going to find two asymptotes. One will go this way, and one will go that way. And then what we'll do is we'll draw a line from our conjugate axis, here and here, and then a line at our vertex. Okay, so if we can find B, and if we can find A, and we have the vertex as well as the B distance up here, we can draw and make a little box. And then from the center point through each of the corners here, well, this doesn't really show it through the corner because I'm a bad drawer, and here we've got our asymptotes, okay, without even trying. Actually, the formula for the asymptote is here, it's b over a, plus or minus, and down here it's A over B plus or minus. And we'll get into that in a little bit, but you really don't even need these in order to graph it. You just need to know where the center point is, the vertices, and then the B points, the ends of the conjugate axis. Draw the square, draw a line diagonal there, a line diagonal there, and then in order to draw your hyperbola, you just draw kind of along the asymptotes and just touch the box for your vertex there. So anyway, we'll get into doing some of those in a minute as soon as I get rid of my mess here. Alright, so let's look at example 1. Now in example 1, what they're doing is they're giving you some information here. Let's make that up there. They are telling you that your vertices are 0, -4, and 0, 4. Well, that's telling you right there that, that our graph is going to have, for our vertices, 4 and -4. And our whatever line our vertex is on, or vertices are on, is going to tell you that we're going to go this way and this way. Okay, so it's going to look like that one there because our vertices are on the y-axis. Okay, so they gave you the vertices. They give you the foci being 0, -6, and 0, 6. Alright, one thing to notice here. The y's have values here and here. They have to because the vertex and the focus are on the same line. They're either horizontal or vertical. Alright, so what else do we know? We know, according to this here, that the vertice is -A0, A0. So we know, or I'm sorry, we're down here because it's a vertical. We know the foci is -C and C. So -6 and 6 is the foci. Okay, so we can say that C equals 6. Okay, we also know that A, if we look here, vertex has an A. So the vertex is 4, -4, or A is for the distance from the center to one of the points on the vertex is 4. Now, notice it's so from here to here it's 4. From here to here the distance is 4, but it's in a negative direction. So A is actually, how far is A from the center point? Well, it's 4. Okay, so that means B we don't know yet, and we do need to know B because, look, the formula has a y² over a² minus x² over b², so we do have to know what the B is. But right here it says that we can use this formula, so we can say 6² equals 4² plus b², so 36 minus 16 equals b². So 20 equals b². Or b equals 2 square root of 5 if you wanted to reduce that to just b. But, you know, we never have to find out what b is because it's asking what b² is. So b² is 20. What is a²? a² is 16. And we don't care what c is because there isn't anything but a and b there. So we have y² over a², and we said a², a is 4, so a² is 16, minus x² over b² is 20, equals 1. And that's the answer for that. We had to find A, we had to find B. That's all we need to do in order to find the answer here. But since they gave us C, and we didn't know B, we had to use c² equals a² plus b² in order to find B, so we could put it there. Okay, so remember, this is b², and this is a². Alright, so let's look at example 2. Okay, so I'm feeling like I'm kind of going in circles and going all over the place for some reason. I just don't feel like I'm being very clear. I hope I am. If I'm not, let me know. Alright, so what they want us to do is find the vertice, the foci, and the asymptotes, and then graph. Alright, so this is standard form. This is not in standard form for a hyperbola, so we need to do that. Now, one of the things that you'll notice here is both of them are equal to 1. Well, this is equal to 144, so I need to make it a 1, so I'm going to divide each part of this by 144. And then that makes it x squared over 16, because 9 goes into 144 16 times, minus y squared over 9 equals 144 over 144 is 1. Okay, cool. Now what does it say? It says that we have to put it this way. Okay, the x is first, so it's going to be this one because the x is first. Alright, so a squared, that's a squared. So actually this needs to be, and that's 3 squared. Alright, so a is 4, b is 3. Okay, so that's good. What's c? Well, I don't know, so I'm going to have to take a squared plus b squared equals c squared. So I'm going to get 16 plus 9 equals c squared. So 25 equals c squared, or c equals 5. Okay, so now I've got a, b, and c. So let's look and see what we're doing here. We've got an x squared first minus y squared, so it's going to be this one here. Alright, so let's find the vertices. Vertices equal, according to this, whatever a is, we'll make it negative, and then positive. And then the foci is whatever c is, negative and positive. So c is 5. Okay, and what else do we find in here? The asymptotes. Alright, the asymptote is plus or minus plus or minus b over a. So the asymptotes are plus or minus, what's b? 3/4. Okay, so let's move this out of here. Oops. Let's move this up a little bit and get our graph. Alright, so it's telling me my vertices are 1, 2, 3, 4, 1, 2, 3, 4. So there's a vertex and there's a vertex. So I'll tell you what, I'm going to run out of time on this, so I'm going to take a picture of this and put it on the next video so we can go from there with it. So let's just stop here.